Next, the circuit is Zener diode has voltage regulator. This is the connections of the Zener diode has voltage regulator circuit diagram. Now, this is the connections of the Zener diode voltage regulator. If you observe here, anode is grounded anode, cathode is connected to here. Resistor, given input to the resistor. Positive terminal to resistor, negative terminal is grounded and connected only one voltmeter. Voltmeter positive terminal to cathode and negative terminal is grounded. Okay, if your connections. Next, here we are using one more operator, DRB, decayed resistance box. By using decayed resistance box, we are observing the output. Now I am disconnected from the circuit. Okay, just now I am using noting V no load. First, apply the 10 volts from the RPS. 10 volts. Whenever we apply 10 volts voltage, it shows the Zener breakdown voltage. That is 5.22 volts. Okay. That is V full load. Applied 10 volts from the regulated power supply and observe the voltmeter reading. It is 5.22. That is called breakdown, Zener breakdown voltage. This is the connections of the Zener has voltage regulator. Now one more operators are we are using here. Decayed resistance box. This is the decayed resistance box. Now we are using 100 ohms to 1 kilo ohm. 100 ohm into 900 ohms, and keep this one into 0 position and move this one into 1k into 1 kilo ohm. Okay, clear it. 100. First I am keeping it. This is called 100 ohm. Next 200, 300, 400, vary like that. This is the Zener voltage regulator connections. Diode anode is grounded, cathode is connected to the terminal. Voltmeter connected. Okay. Next. Now this voltage is called no load voltage. VNL, no load, 5.22. Note it, V no load voltage. Next, we want V full load voltage by applying regulated power supply. Sorry, decayed resistance box. Decayed resistance positive terminal I am connected to the common point. Negative terminal I have grounded. Okay, positive terminal connected to this common point in middle. Negative terminal I have grounded. This is the connections of voltage regulator. By varying the, whenever I connected voltage decayed resistance box, if you observe here, it shows 0.11. Load, if I connected load, is showing now vary 100 ohm and observe the V voltage, 1 volt. We have to measure like using truth tape. Resistance load means decayed resistance box 100 ohm to 1000 ohm. Next voltage and percentage regulation. VNL, we have to here notice VNL is called 5.22 volts. Here not mentioned here. The formula of the percentage regulation, VNL minus V full load divided by VNL into 100. VNL means before we have observed, without no load we have observed. If I disconnected no load from here, if you observe here 5.21, that is called a V no load. And I applied, it shows 1.01. Given volt decayed resistance box ohms 100 ohms. It is. Again I am changing 200. Okay, 300. If you are observing the changing, 4. Changing it slowly, increases. Next I kept this one is 0 and using 1k, 1 into kilo ohm. 584. This readings now we are using observing readings are called V full load. That is V full load readings. These all are called V full load readings. RL. What required VNL before we noted 5.22 volts minus V full load means this value divided by VNL 5.22 into 100. That is the percentage regulation. Okay. If you observe, this is the model graphs of the voltage and current characteristics. Here voltage is constant. That point is called Zener breakdown voltage. Here it is working as a normal PN diode. It is volt regulator characteristics. Regulation voltage regulator characteristics. The model draw. This is the Zener voltage regulator experiment.